Okay, so we got this problem and it wants us to simplify this expression. So we've got the fifth root, change colors, fifth root of 486, x to the 10th, z to the 11th. All right, so the first thing I'm going to try and do is I'm going to try and factor this 486 into different stuff so I can see if there's maybe something that'll cancel with that fifth root. So I'm going to start with 486. I see that I can pull a 2 out, so I'm going to divide by 2, and I'm going to get 243. All right. I see that that's divisible by 3, so I'm going to divide by 3 here. And I see that I get 81, and I know that 81 is 9 times 9, and 9 is 3 times 3. So I know that 486 factors into 2 times 3 to the 1, 2, 3, 4, 5. 3 to the 5th power. All right, so I'm going to go ahead and substitute 2 times 3 to the 5th for my 486 in my fifth root here. So I have 2 times 3 to the 5th times x to the 10th times z to the 11th. All right, and so one property of square roots that I'm going to use is if we have the cth root of a times b, this is the cth root of a times the cth root of b. All right, so I'm going to split up this fifth root into 4 separate fifth roots. So I'm going to have the fifth root of 2 times the fifth root of 3 to the 5th times the fifth root of x to the 10th times the fifth root of z to the 11th. Then from here, I'm going to use the property that if we have cth root of a to the c, this is a. The cth root and the c power kind of cancel each other out. So you kind of just are left with your thing that you are raising to the c power. So in this first term right here, the fifth root of 2, there's nothing to the fifth power. So I have to just copy and paste that. I have the fifth root of 2. But in this next term, the fifth root of 3 to the 5th, the to the 5th power and the 5th root will cancel each other out. So we're just going to be left with times 3. All right. Right here, this x to the 10th, I'm going to rewrite that for now as x to the 5th times x to the 5th. Because it's another property of exponents that if we have a to the b times a to the c, this is a to the b plus c. I'm kind of using it backwards. I know that 10 is 5 plus 5. So I have x to the 10th is equal to x to the 5th times x to the 5th. That's what I'm kind of using in this step here. And I'm going to do the same thing with this next one, this fifth root of z to the 11th. I'm going to have the fifth root of z to the 5th times z to the 5th times z to the 1 power. 5 plus 5 plus 5 is 11. So I'm using this property again. All right. From here, I'm going to move this 3 in front over here just so that it's like out of the way and so it's not messing up with anything else. And I'm also going to use this property up here that we used where we were able to split up our cth root, our fifth roots we were splitting into 4. I'm going to do that the same with these x to the 5th and z to the 5th terms. So first thing I said I was going to do was I'm going to move that 3 to the front. I still have to copy and paste my fifth root of 2. And then I have the fifth root of x to the 5th times the fifth root of x to the 5th times the fifth root of z to the 5th times the fifth root of z to the 5th times the fifth root of z to the 1. All right, so I split this into 2. I split this into 3 here. I can do that by this first property right here that I have starred. All right, so I get 3 times the fifth root of 2. And then I can use this property right here. I'm kind of squiggling next to right here, where the fifth root and to the fifth power cancel each other out. So I'm going to be left with times 7 times x times x times z times z. And this fifth root of z to the 1, I don't have 5 z's to cancel out with that fifth root. I just have 1 z. So I still have to copy and paste it down here. Z to the 1, like I did with the 2. All right, I'm going to group like terms. This x times x is going to give me an x squared. This z times z is going to give me a z squared. And I can move those in the front with the 3. So I get 3x squared z squared, fifth root of 2 times the fifth root of z. Alrighty, and I'm going to use the property from earlier backwards. If I have the cth root of a times the cth root of b, this is the cth root of a times b. I'm going to use that here. So I'm going to get 3x squared z squared on the fifth root of 2 times z. And that would be my final answer.